from our palatial recording facilities high atop our mountain lair on a remote volcanic island. This is Talk Universe. I'm Sir Charles Schultz.
And I'm Eliza, your co-host. This is our show for Wednesday, April 26th, 2017. Tonight's topic is What's Really on Mars Part 3.
Yes, and we have an interesting guest tonight. Eliza,
What shall I do for you?
who is our guest tonight?
Our guest tonight is Barry DiGregorio.
Yes, and he's a fascinating fellow. I think that we're going to have a lot of fun with it. He's an astrobiologist. This is a show that is the third of our Mars series. We've got 6 parts coming up. The first 2, of course, we've already done. We're looking tonight at signs of biological activity on Mars, and I think this is a show that many people are going to really like. We have covered many different elements of the research on the planet Mars and information from NASA and the European Space Agency and others. We're going to get a really close look at what appears to be biology on Mars, and we're going to look back at 1976 with the Viking project. So I'm going to get into the interview with Barry DiGregorio very shortly here. Please read our guest bio.
Barry DiGregorio is an astrobiologist who started his career studying the geology of the Great Lakes. He has worked with data from various Mars projects starting with Viking and has written 2 books on the subject of life on Mars. He is an honorary research fellow for the Buckingham Centre for Astrobiology in the UK.
And a very
I
distinguished...
should read the biography for the listeners.
Yes, you've just done that. Thank you. And to be honest, it is a much longer biography, but we'll get into many of the details a little bit later in the show. He's done an amazing body of work, and we've had a number of conversations on the subject. I believe that the information he presents on the show tonight will be fascinating, and I think that you should really hear this. Our listeners are interested in technical things, and normally we expect science to proceed in a well-known and predictable manner, to follow the mystery questions and figure out exactly what's going on, honestly and openly. And I think that anybody listening to this interview and what Dr. DiGregorio has encountered will get their eyes opened a little. So we're going to get right into the interview here. Stand by while I connect. So, Barry, welcome to the show.
Thank you, Charles. Great to be here.
Okay, well, you've done an extensive amount of work on Mars and the potential for biology on Mars, and I'd like you to give us a little bit of your findings so we can understand just how impressive it is and how relevant it is.
Well, really, I began with my interest in the study of Lake Ontario and, the development of the Great Lakes and, just what it meant to this area alone in a geological context. I was always fascinated by the geology of the area because, you're living next to Niagara Falls, one of the greatest wonders of the world. And when you go down in the Niagara Gorge and see all those rock layers, you got to start asking yourself questions. If you're serious about learning, the origin of the Great Lakes. So that's how I started out, really. And this led to me somehow becoming an astrobiologist after so many papers and research articles and reading thousands of scientific papers. So here I am today.
Was this where you first came across the rock cavities that interested you so much, the Ordovician structures?
Yeah, at that time I was reading a lot of information coming out about the ocean on Mars, the Oceanus Borealis. And, at the time it was fairly new. I believe Victor Baker and Robert Strom were the authors of an early paper called Ancient Ocean Land Atmosphere Interactions on Mars. And they came out with a global model and geological evidence for an ocean in the northern hemisphere of Mars. And, it was heavily debated back then, of course, but as I read their paper, I couldn't help but see certain parallels to what happened here on our planet, not far from where I live, on the shores of Lake Ontario.
Sure. Well, wouldn't you say that the findings of salts on Mars have pretty much clinched the fact that there were oceans in the past?
Oh yeah, well, it's the salts, the deltas, the shorelines, the rampart craters, the snowfall, the water droplets on the Phoenix Lander struts. I mean, there's a lot of evidence for current water activity on Mars.
And so we're not talking billions of years ago necessarily. Some of it is actually happening today.
Yeah, exactly. And, the fact that the rovers and landers that have been sent are designed to look for ancient water is a bit mysterious at best.
Well, I was always a little puzzled by the fact that out of the Mars rovers, the exploration rovers, Spirit and Opportunity, neither one of them had any water detecting hardware of any sort, and it was a follow the water mission. What was your feeling about that?
Well, my feeling was just that. You're only looking for ancient water. What about the type of water that could, say, keep a colony of microorganisms alive? And that was the real issue for me because I got started with the Mars, whatever you want to call it, the interest in life on Mars with the Viking mission, of course. I remember opening a 1977 issue of National Geographic, which, basically had a titled article, The Search for Life on Mars. And after I read that article, it really changed the way I thought about the planet. Prior to that, I had read about, William Sinton, who worked out with the Palomar telescope in California. He discovered what he called the Sinton bands, which were, evidence to him of chlorophyll. And,
Right.
that kept everybody in line asking questions about life on Mars until Viking came around, the very first mission to search for life on Mars. So
Sure.
in that article, in that National Geographic article, Gilbert Levin was mentioned in there, and he was saying that it's too early to say that Viking didn't find life. I mean, here he was in National Geographic saying, my experiment looks like it found life, but because the experiments were still being analyzed, he didn't come out with a concrete conclusion at the time. He just kept an open mind. That it also opened a lot of other minds as well.
Sure, and I know that had a lot of effect with my interest in the planet as well. And I know that in the article, I think that if I'm not mistaken, that was the one that was illustrated by the painter Ludwig Pesek, and it's stuck in my mind all this time. And they had mentioned that it might have been as little as 50,000 years ago that there was serious water on the surface of the planet. That really affected me.
Yeah, and so, here I am, a person really interested in the geological history of the Great Lakes, how the lakes were formed. The history, just goes back to about, 4.5 billion years ago. That's when the place here in New York where I live was about 15 degrees south of the equator.
Mm-hmm.
So it was a different planet at the time, and it was a lot warmer. There was an inland sea here, shallow, salty inland sea, and that's when the rocks that I started studying came from. It came from that time period, the life in the sea, which that was all there was at the time, was life in the oceans.
Right.
As far as we know, that long ago, it basically took hold in the shallow sandy bottoms of the shallow sea that existed then. And when those organisms died, they left body parts in the sand there, which later lithified and became buried. And as Earth went through its various epochs, it came to the glaciations during the Pleistocene, and the massive ice descended down over the region that was once the shallow sea, and gouged out, of course, the the basins for the Great Lakes, and as the glaciers descended, dug up all the ancient seabed and scattered them around. And lo and behold, after the glaciers subsided, these rocks from the ancient seabed became covered with dirt, and other rock and plant life formed on top of them. And as rain fell, carbonic acid coming down and soaking the soil, mixing with humic acids in the soil, you would tend to have rocks like sandstones eaten away over time. And the ancient fossils that were entombed in the ancient seabed were made of calcium carbonate, which is a little more resistant than the sandstone would be. And so what would happen is these rocks would dissolve, and sometimes the fossils would be intact, sometimes they would be partially dissolved, and then in other rocks they would be totally dissolved, leaving just small vugs or dissolution cavities in the rocks. And that's what drew my attention to Mars at the time. I was looking at the images returned from the Viking 2 lander, and I was amazed that, the rocks had so many cavities or vugs, or, there's a number of different names, scientists call these things, but the first thing the planetary scientists looked at was, we see holes in the rocks. That means volcanic activity.
Instead of admonishing the possibility that water might have done it, it had to be volcanic.
Right. There was this great resistance against the water idea because we knew that Mars had an atmosphere 1,000th that of Earth. So can't possibly have water there because the pressure would be too low. And, nobody was thinking of, what about several million years ago or a billion years ago?
Well, Barry, one other thing that I'd like to interject is many people today tend to think that things are the way they are and they've always been this way, and it seems rather short-sighted to me for a geologist not to think in geological time spans that the atmosphere might have been substantially different in times past, and certainly it was.
Yeah, you're absolutely correct. And I think today, a lot of planetary scientists and people in the field of astrobiology recognize this. But, the hard thing to understand is this reluctance on the part of NASA to actually go there and look for, extant life. I mean, here you had a scientist on the first search for life on Mars in 1976 saying he had some really good positive evidence, and he's maintained that for 40
plus
years. So, why aren't we going back to expound on what he found?
Certainly, there's been no actual life-detecting hardware used on Mars since then.
And that really got my curiosity up, if you don't mind the pun. But anyways, I sought out Gilbert Levin. I was working as a science writer, for a magazine called Final Frontier, and I set up a little interview with him, and it was the first chance I really had to talk to him. I think it was 1992, maybe. And that interview actually blew my mind, because here he was, the guy that I read about in National Geographic, having said that there was a possibility his experiment found life on Mars. Here I am talking, and he's still insisting that the data need to be looked at. But he didn't really come out and conclude in a very definitive way until I decided to write a book about him and the LR experiment. I told him that I thought that it was really important for people to understand his story because it was a story of resistance. It wasn't a story that you think that science would follow. I mean, usually when you make a discovery, an important one, where you think you have, the idea is to, get the data, see what you got, and then, plan a follow-on mission to see if that is indeed what you found. But instead, mean, usually when you make a discovery, an important one, or you think you have, the idea is to, get the data, see what you got, and then, plan a follow-on mission to see if that is indeed what you found. But instead, they immediately started to hypothesize his hypothesis away. I mean, they came up with all kinds of things, all kinds of reasons that life couldn't be there and why his experiment couldn't have found life. And as we moved on through the years to the point we are now, I mean, if anything, his argument has gotten stronger. So.
Yeah, absolutely. In fact, I see a lot of things that appear to be signs of life on Mars, and many of the images I look at, and not just the images, but also a lot of the chemical and physical data as well. And this is an important thing. A lot of people will look at some pictures and go, well, that obviously was alive. But you have to analyze the other data as well, or you don't have a foundation for your beliefs. And a lot of people say belief is the beginning of, or I should say it's the end of reason. And maybe that's the thing here. They've settled on a belief, and they're using every means they can to defend it rather than to find out what the facts are.
Well, I think it goes beyond that, Charles. I think actually there was resistance to Levin's data, because I think a lot of the scientists working at NASA at the time thought that he may have found life.
Sure.
And whoever took charge of the missions after that very deliberately made sure that only a select few people could submit successful proposals. And
right.
I've had some personal experience in that field myself, which I'll talk to you about in a bit.
Certainly.
But for Levin, it was a journey of disbelief that his peers would reject all of the data and then be forced to get into this geological hunt for ancient water on Mars. When, you had two polar ice caps there that are plain to the eye. The Viking mission also revealed that it was snowing, water ice.
Certainly.
It remained on the surface of Mars for, I think, 200 sols or days on Mars, and nobody seemed to put two and two together.
Well, what strikes me, and you're absolutely right on it, what strikes me is that when the Phoenix lander was out of commission, when they finally found it, the panels on it had collapsed, and nobody would say, well, it probably snowed on it, and the weight of the snow broke the panels. And, that seems kind of reasonable. We were told at the time that any precipitation falling to the Martian atmosphere would never reach the ground. But, clearly they're ice caps.
Yeah, and not to mention the water droplets themselves on the landing struts.
Yes, please tell us about that.
I mean, any scientist, looking for water on Mars, there it is, right in front of you, dripping off the lander struts. I mean, what more do you need?
Certainly.
And then, of course, the ice just below the soil, maybe in, just a few centimeters or so.
In other words, it landed basically on what appears to be a deposit of ice and a few centimeters of soil, a couple of inches of soil on top of it, and the hydrazine engines disturbed it and blew the water up on the landing struts, and those droplets stuck there and froze. Is this a correct summary?
I'm thinking it might be, but, the Martian atmosphere does get saturated.
Certainly.
And that water vapor gets absorbed in the soil.
Right, and the salts, in my opinion, and we did some experiments in our laboratory, we found that when you put that much salt in a soil sample, it would absorb humidity out of the air. Salts are hygroscopic, they pull moisture out of the air, and it would become damp and clumpy, and it would exhibit exactly the properties we saw on Mars today with the wheel tracks and other issues.
Taking it back to, the Viking 2 landing site.
Yes.
I think it was in 2009, the Mars Reconnaissance Orbiter used its hyperspectral imager called XRISM to look down at the plane there, which is a very flat plane, indicative of an area that was covered by water. And what they found there was absolutely a shock, because right there, right around where the Viking 2 lander set down on Mars in 76, they found that had the arm on Viking gone down another couple centimeters, it would have hit ice, water ice.
Yes.
So what we're saying here is, the area which they, Strom and Baker had earlier suggested was the area in which an ancient ocean existed, was a few centimeters below the soil ice, and they found it all over Utopia Planitia. So you couldn't have better evidence for what happened to at least some of the water than that. I mean, it's probably frozen below the soil. But when you get to analyzing, the data from the labeled release experiment designed by Gilbert Levin, you not only see that there is some evidence of microbial metabolism in your experiment, but you really had a lot of water ice to be available to any kind of colonies that might still be living.
In other words, it's not such a desiccated environment after all, and we could tell that from the supersaturated atmosphere. It has roughly 10 times as much moisture as theory says it should carry.
Yeah, and that's what really bothered me about this whole thing, is this constant denial. And, why couldn't there be, life at either of the Viking sites? And then all of a sudden just to decide, well, we're not going to look for that anymore. We're just going to go on to look for signs of ancient water.
Right.
Which completely didn't make any sense at all. So
well, it's as if they want to push off the possibility of life to a billion years ago, but not today.
Yeah. And that's what really got me started with the idea of, what the Planetary Protection Program at NASA was all about.
And now, please do go on. You got an International Committee Against Mars Sample Return. I know you're going to get into that. Please tell us what your thinking is on that and why you started that.
Well, I have to tell you that it was really Levin himself that really inspired me, him and Carl Sagan, if you want to pronounce it that way. But Carl Sagan was an extreme personality for wanting to protect planets from forward and back contamination. I mean, during the early talks where JPL was considering maybe an early sample return mission, he voiced his opinion to them, to the engineers, saying which one of you would be willing to send up Ebola on a Mars trajectory course and return it to Earth and have it come down in his city. If you feel comfortable with that, perhaps we could do a Mars sample return. And then, the conversation started, that the Apollo astronauts might return with some sort of microorganisms, attached to the dust grains on their suits and things like this. And protocols, I call them false protocols, were put into place. The original idea for Apollo 11, returning the moon rocks, was when it came down and entered the ocean that the whole capsule was going to be picked up and brought on board the ship
still
and
sealed,
washed down.
Yes.
Excuse me?
Still sealed, yes.
Yeah, still sealed and washed down with a germicide. And then they were going to go into their trailer, which was a joke, because in Buzz Aldrin's book, Men from Earth, I think he says that he thought it was a farce because he could see ant in from the outside to the isolation trailer in which they had to spend a few days. But even before then, while they were in the ocean, it was decided that the astronauts were much too important and that we had to save them first. So they opened the door in the ocean, and if there were any microorganisms on the moon,
they'd be
guess where they are now.
Sure.
So here you have, a prime example of you have laws put into place not to contaminate planetary biospheres, and the very first thing we do with the samples from the moon is contaminate our biosphere. Fortunately, we didn't do anything disastrous, but that doesn't mean that that will always be. So Gilbert Levin was on an early Mars quarantine panel. He actually had a mission patch, and he drew up probably the first Mars sample return document. I have a copy of it. NASA paid him, his company, Biospherics at that time, to have him draw up the first sample return proposal, which he did. But he was against it. He thought it was a really bad idea, and subsequent meetings after he wrote up the proposal said that he did not recommend bringing soil samples directly to Earth. And this was before,
Sure.
all the knowledge had been gained about, the atmosphere and any water. So he was sending out a warning signal then.
Well, I think people had a little bit more on the ball in the past than we give them credit for, and we seem to have lost a little bit of our sharpness in recent decades, and I don't understand why that is. We have to consider anything that has the potential of having life at some point as a potential threat, because if there does exist any sort of living organism in a sample from another world, we would certainly have no resistance or immunity ability against that organism. And if it turned out to be something dangerous, we could have a real problem.
Yeah, the late Carl Woese, explained to me that that is the worst idea he had ever heard. Before his death, I did an interview with him, and he just was adamant about not returning, soil samples from Mars. So he said it's not the point. Bringing it back would be disastrous. He says NASA must prove first that it wouldn't cause a disaster before they bring it back. So I think what we're seeing today is basically camouflage, in my view, from where I am. I think that, with all the money being pumped in for a human mission to Mars, that the last thing we want to do is kill all this cash flow for this program by telling people that they could be infected, and worse yet, the Earth could possibly, the Earth's biosphere could suffer from it.
Sure.
So I think
go right ahead, please.
There is great resistance towards anybody like myself who tries to sound an alarm about Mars sample return.
Well, don't you think it's odd when we consider the possibility that people traveling to Mars in 7 to 10 month life, of the mission, would probably get about half a lethal dose of radiation, as it's been said. But not only that, if they were to come back to Earth, they'd almost surely die if that were the case. It would be a death sentence. But I see two reasons now not to allow anyone who goes to Mars to ever return. And one is the radiation issue that they would accumulate, and the radiation dose. And the other one is, of course, the possibility of infection.
Right. And every time I hear this, Elon Musk and his quest to send people to Mars, every so many months, it sounds like a science fiction story. Science fiction at its finest. I mean, you're going to send these people there without knowing for sure if there's anything alive in the soil, which there is some data for.
Right.
And is the purpose to see what it does, horrifically?
No, I don't even want to think about that. I mean, now I have to admit, I have a great love of a great engineering task, and getting live humans to Mars is an amazing engineering task. But at this point, to be honest, as much as I would just love to go, I cannot think of any reasonable argument in sending human beings to Mars right now. And if you did go, I would never want anybody to get any closer than, let's say, Phobos. They could put a base there and analyze it from there and run telefactors on the surface. But as for people landing on the surface, we just don't know enough about the conditions and what could happen.
Exactly.
Well, so tell me something else. Now, we were both discussing a little earlier the potential for signs of what appears to be biological action on Mars when we talked earlier. about the conditions and what could happen.
Exactly.
Well, so tell me something else. Now, we were both discussing a little earlier the potential for signs of what appears to be biological action on Mars when we talked earlier. And one of the things we've both seen is the desert varnish. And please tell me about desert varnish, if you will.
Well, supposedly, desert varnish has been argued for at least the last 150 years as to whether it is abiotic or biotic in nature. Basically, it's about 30 to 40% iron oxides and manganese oxides, along with the rest being clay minerals. And for thousands of years, the Native American peoples have used it as a sort of easel to put images of animals they used to hunt and pictures possibly of their gods.
The petroglyphs.
And petroglyphs, yes, that you can see in the Southwest desert. And most of the research that has been done on rock varnish has been in warm deserts. And it is only recent that researchers interested in the subject have taken to looking for, rock varnishes in places like Tibet, mountains, Antarctica, the Amazon, and incredibly, rock varnish exists in all these environments. And, if it is indeed a biosignature, and there's a reason for it being on the rocks in deserts, then you would want to investigate it, since Mars is a rocky planet.
Right.
So early reports from Viking showed to be what were reflective coatings on the rocks. Since Viking was not a rover, it couldn't go over to the rocks, really, and take a sample or scrape it or whatever.
Certainly, it was limited by what it could see.
Yeah, but it became almost routine to see these types of rock coatings on each preceding mission. Mars, the rocks at Mars Pathfinder had rock coatings covering their surfaces, both thick and thin. Some suggested that there were varnishes there, coatings of silica glaze, carbonate coatings, calcium sulfate, which we know to be in abundance at Gale Crater. But the varnish, if it is biological, then we have a biosignature for planets that have rock varnish. And, lo and behold, the Curiosity rover lands, and they start investigating rocks in Gale Crater, and they start finding manganese oxide coatings on many of the rocks. As soon as they found it, they almost tried to, well, they did. They actually eliminated any talk of a biological production of the varnish on Mars. Instead, they said, all this manganese means here is that we're seeing, possibly evidence of a lot of oxygen in Mars' atmosphere at one time.
Well, wouldn't you think that over this period of time that such a coating would have worn away simply from dust blowing over it, if that were the case?
Yes, you're right. And that's exactly what happens in deserts on Earth as well. The fact, though, that, some deserts have outcrops of rock varnish that have been dated at 40,000 years plus says that it has some durability.
Sure.
Okay, so, but here you have a planet that has entire hemispheres wrapped in dust storms that last for months. You would expect that varnish would be eroded away. So any scientist interested in the subject would have to ask that question. Why are we finding these coatings here?
In other words, it's something that would have to be generated again and again because erosion would be removing it.
Right. And so, I, along with several other scientists, proposed an experiment that could be done with the Curiosity rover to find out if those dust coatings would be removed, and we could analyze the rock varnish, which wouldn't take much. You just have to scrape a little off and put it in the SAM instrument to see if you're looking at any organic. Up to this point, they've just been drilling in rocks. They haven't really looked for organics in anything else but rocks.
Right.
But they haven't looked at these coatings, which might be direct evidence, for extant life on Mars today.
It's right under their noses, and they're not actually looking at it.
And in the papers that they write about manganese oxides, they don't really even refer to any papers that, offer a biological explanation for this.
Yes.
So you want me to continue on the varnished?
Well, I think you
stuff?
pretty much covered it. I mean, what it comes down to is we see rock varnish on the Earth, and it's often associated with, biological entities, organisms. There are two particular microbes I'm aware of on Earth, Petomicrobium and Metallogenium, that are often found associated with rock varnish or desert varnish. And we also see desert varnish in many of the images from Mars from many different landers and spacecraft. And NASA has not yet done an analysis to say one way or the other what we're seeing, whether it's biological or not.
Right. And that's why the paper that we just completed for the Journal of Geology is so important, because we have found rock varnish that we can precisely date to when it started forming. And we can see, the budding bacteria, and you can actually calculate how many, of these budding bacteria it would take to form the thickness of the coating we see. So this is the first time, really, I think, that such a fast-growing rock varnish has been observed and proven beyond a shadow of a doubt that its cause is biological. So
those are your findings at the Erie Canal, correct?
Yes, correct, yeah.
Well, that's fantastic. So you actually have a lineage from the generation of the coating and a period of time and a mechanism, and it all ties together coherently. And so this should be sort of a benchmark to compare these readings against on Mars.
Right, but, you have to be willing to examine the coatings in detail, not just report the chemical analysis. I mean, organic analysis would be great, and it would be easily done.
So in summary, I would say that you are standing staunchly in the corner of there is biological activity on Mars, and we're not talking about anything complicated, but microbial life even would be a major finding, and I believe that you're a strong believer in that based on the information from Dr. Levin and Dr. Straat and your work as well.
I think the data is overwhelming.
I agree with you. Well, Barry, I thank you so much for this interview. It's an eye-opener, I think it will be for many people when they hear. And, you and I have briefly discussed many of these different things, but, wow, we could do hours of talk on that alone. But I think that you summarized it very nicely for the listeners, and I'm honored that you came on the show, and I appreciate all the information you give us during this interview.
Well, it was my pleasure.
Okay, thank you so much. And I'm going to end the recording.
Have a good evening.
Thank you. Wow, what an interview, and a real honor to have Dr. DiGregorio on the show. And I know that he's fighting a couple of interesting battles right now. And one of them is a project that he was working on for identifying organisms using the Curiosity rover. And he made a presentation, and the European Space Agency was very interested, and funding was made available. They presented this project to NASA. NASA sat on it for a number of months before saying yes or no. They finally said, no, we're not interested in doing it. And then they turned around and did it themselves without giving any credit to Dr. DiGregorio and his team and the work that they were doing. So this is really, well, it's dishonest. Let's face it. NASA had an entire project laid in their lap, and a foreign government interested in funding it. And then they decided to blow them off and do it themselves and take credit for it. So, this is the sort of thing we have going on that many people aren't aware of, and it really devalues our image in the face of the world in many ways. We're supposed to be honest. Science is about honesty above all else, because if you lie in science or if you deceive in science, you've placed a fundamental flaw in the work that you're doing. Now, with that said, I'm going to go ahead and do our book recommendation. Eliza?
How can I help you?
Let's do the book recommendation, please.
This week's book is Mars, the Living Planet. It was written by Barry DiGregorio with a foreword by Dr. Gilbert Levin. This book was published in July 1973 by Frog Books.
Now, many people may remember Dr. Gilbert Levin was the fellow who designed the labeled release experiment, which was sent to Mars on both Viking 1 and Viking 2, and they landed on Mars in 1976 and found what appeared to be very clear evidence of biological activity in the soil. And there were a number of experiments done. One of the controls they did was they brought in a sample of the Martian soil, and it showed what appeared to be biological activity. They emptied and cleared the chamber. They brought a second sample, and they heated it to about 65 degrees centigrade to hopefully sterilize anything that might exist in the sample. When the repeated experiments with the heated soil sample, no activity occurred. And all the experimenting that they did on Earth to try and replicate the results with non-biological methods, such as chemicals in the soil, failed to replicate what their findings were. So it seemed very clear that if you put a sample of the soil in the test chamber and it wasn't cooked beforehand, activity occurred. And if you did cook it to, ostensibly sterilize it, activity did not occur. Now, this is the sort of thing that if you said, well, that's not proof, well then great, send another mission with life-detecting hardware that's designed specifically to eliminate the possibilities of error and verify what you've done. And this is what Dr. DiGregorio was referring to. The fact is, we have not sent any biologically capable hardware for sensing life to Mars since 1976. And the question is, why not? We have data that appears to show what is biological activity, and the rock varnish. This is the other issue. On Earth, nobody has shown a non-biological method of forming rock varnish, and it's found in many different environments now that we've started looking for it, and Dr. DiGregorio found rock varnish that grew at a known rate, and they know that because the rocks it's on were formed during the building of the Erie Canal. And his discoveries showed an actual rate of budding and growth that corresponded with the thickness of the material, and is a strong support for the theory that rock varnish is biologically produced. If NASA admits this, then they have to admit that all the rock varnish we see on Mars is produced by biology. This is not a mineralogy phenomenon, and no mineralogical explanation adequately explains what you see in rock varnish. That's something that you can see in the cameras, in the lenses, in all of the images. You see rock varnish on Mars. And it's produced, it's produced by microorganisms. So NASA has sidestepped the issue, ignored it away, and is failing to analyze what is clearly, in many people's opinions, signs of biology on Mars. And so the question is, why are they doing this? And, now some people are going to say, hey, this is a conspiracy theory. No, this is a fact. We see this. It's measurable. They fought for years against the fact that there is water, and plenty of it, on Mars. It isn't rare or hard to find. The atmosphere is supersaturated. It's carrying 10 times more moisture than theory suggests is possible. Well, the answer to that's very easy. If I took a simple cylinder and put a few spoons of water in it and sucked the air out and sealed it, the water would boil and the vapor would fill the cylinder until it created its own atmosphere of water vapor. And water vapor in that context is called steam. And the steam clearly is a part of the Martian atmosphere that is not being accounted for. In other words, the atmosphere is partly water vapor, not just carbon dioxide, nitrogen, and argon. That simple fact accounts for much of what we see. And there's a process called advection that goes along with the evaporation of moisture that easily accounts for the loading. And we'll get into that in a little bit. There's a fellow by the name of Derek Sears who did some amazing research, and showed that the water vapor has a much greater effect and has much more persistence in the Mars-like environment than has been accounted for. You can't live by what comes on a physics table. Well, this is the property of water, because the real world is a dirty place. There's salt, and there's dust, and there are conditions you don't account for that don't happen in a sterile laboratory. Eliza?
Yes, Charles?
Be a dear and introduce the break, please.
You are listening to Talk Universe. I'm Eliza, your co-host. We will be right back.
Indeed we will, and there's a lot more to say about Mars and some of the findings of Dr. DiGregorio. So stick around and listen for our final segment here. You're listening to Talk Universe. So we're down to the final segment of the show, and there are just so many questions and so many things to consider. We have what really is visible to the eye, perfect evidence that there's plenty of water on Mars, and the chemical and physical evidence that's been recorded by the rovers verifies that, and studies with the Hubble Space Telescope even show us the cloud composition. 50% of it is water droplets, 50% of it is water ice. Interesting, interesting. And even though we've been told that precipitation on Mars would never reach the surface, we do see snowfall, and we do see frost and ice crystals, and numerous things like, as Barry was mentioning, the water droplets frozen on the legs of the lander. So we know that there's plenty of water and ice just literally 2 to 3 inches under the surface of the soil in many cases. Later studies showed it was all over the planet, and it's hard to ignore the fact that a planet that's quite similar to the Earth in many ways. It's a rocky world. It has deserts and winds and craters, and dried up stream beds and ocean beds. It's hard to deny the fact that such a world with water in abundance should support life. And even if something only lived 1 billion years ago or more, nothing would have eliminated all the life on the planet. I mean, life is persistent if nothing else, and we know that from experience on Earth. So when we have evidence of what appears to be biology, and basically what that was is this labeled release experiment that Dr. Levin did on the surface of Mars in 2 different locations back in 1976 with the Viking landers. And we're getting evidence back from those experiments back then that indicated biological activity very clearly. And, he's a humble man, and he was reticent about actually saying, yeah, we found life. He held back and said the data had to be analyzed for many years. The fact is, it's over 40 years now, and NASA has failed to address the question directly. They've sidestepped it. They obfuscated. They said there wasn't water, that was very rare, and yet it is present, and it's everywhere. And they have admitted that, but they've not made the deal out of it that they should have. It's almost as if they're just uncomfortable with the fact, and they don't really say it's there. And often you hear them say, well, yeah, there's some water on Mars, but not where we are. Well, that doesn't make any sense, but okay. And they have not, in all these years, sent another mission capable of identifying whether there is life. They have had devices which could identify some organic molecules, but nothing that could say, yes, this is alive. They had a microscope on the Phoenix lander in the northern polar region, and they really didn't use it. So why did we pay to build a sophisticated microscope and send it to Mars and then not use it? The Follow the Water mission was a joke because they had 2 rovers, Spirit and Opportunity, looking for signs of ancient water on Mars, and neither of them, as Dr. DiGregorio and I have both pointed out, neither of those spacecraft, neither of those rovers, had any instrumentation for detecting water as solid, liquid, or vapor. So how can you have a Follow the Water mission when you have hardware that doesn't have the ability to identify water? And how can you seriously listen to the opinions of an organization that denies that desert varnish, this rock varnish, is created by biology? It's interesting because we have clear and solid evidence here that is being ignored, and people's careers are on hold, in a sense, for decades as a result of it. Our tax dollars go to pay for exploration through NASA, and NASA is not doing the job. Now we're to the point where private individuals are talking about sending missions to Mars, including people, and nobody has taken this head on. If you go to Mars, you cannot come back to Earth until we're absolutely certain that there's no biological activity there. And, we've talked about this previously. Bacteria and fungi could be an issue. All sorts of microbes could be an issue. Viruses would not, in any estimation, because there's no guarantee that the genetic code of an alien organism would be anything near what we have on Earth. And so, if you put the wrong type of floppy in a different computer, it won't read it. And a virus is exactly the same way. A virus is like a floppy disk or a flash memory. And unless the code for the system you plug it into is just right, it can't read it and it can't use the instructions. So viruses wouldn't affect us. And again, that's statistical. We don't think that it would affect us because there's so many ways that you can create a biosystem. We don't really know because we don't have a sample. But desert varnish, or rock varnish, is apparently created by a couple of different organisms on Earth. There might be more. And one of the things that we see is that there are often reversed amino acids trapped in the desert varnish coating. Now, this would be taken as a sign of alien biology. But maybe. What we do see is that desert varnish on the Earth is always associated in some way with microbes. And what interested Barry DiGregorio so much about them was that these microbes have an unusual diet. They eat iron and manganese. They oxidize the manganese to get energy. That's pretty exotic, metal-eating microbes. And the end result is they produce this coating on the rocks. And we see that coating in many of the images on Mars. It's very, very clear. And all they would have to do is grind a little sample of that off and get it in the sample collector and analyze it for organic compounds. That's all they have to do. Now, why is this not being done? I don't know about you, but when my money goes into a project and I see a clear course for that project to follow and it's not following it, and I know that the people doing the project are smart enough to know about that, I have to wonder what's on their agenda. So, one of the things that I've got to do here, and it's very important, I want you to go to our website. It's icamsr.org, icamsr.org. It's International Committee Against Mars Sample Return. And Barry set up that site. He is the fellow who is responsible for setting it up, and he did so on the advice of Gil Levin and Carl Sagan. We've always considered it to be Sagan, but I suppose it was a marketing thing. I don't know. Anyway, they were both involved in the rationale behind it, and Dr. Levin is actually a part of the committee. And the idea is to prevent us from bringing anything back to the Earth that could be a threat. It's very clear that there is, let's say, a very high probability that there is biological activity on the surface of Mars now. And I have been involved in a few things where people have said, well, we've got to bring samples back for analysis. And some of that was even proposed by Dr. Phil Christensen, who is the head of the rover project, the MER right now, the operating opportunity this time. And he said their goal is to bring samples from Mars back to Earth and analyze them. Well, now, let's get some things straight. If there's even the slightest chance that there could be any biological action in it, that could be a threat to our entire planet. And you've got to know these things. You've got to be aware of this. Why would we ever take a chance with infecting the Earth with something? There's clearly biological material present on Mars. They're claiming that the manganese oxides on the rock coatings that they see, were evidence of more oxygen in the past in Mars' atmosphere. Well, oxygen doesn't just come from nowhere. It has to be generated somehow. And biology is the most probable reason for the presence of oxygen. Now, people will say, well, oxygen can get in the air from water molecules being split into hydrogen and oxygen, and from CO2 molecules being split into carbon monoxide and oxygen. That's true, but it's in an environment where it's ready to react and oxidize again. So you don't get enough to breathe. You don't get enough to do anything significant except under very special circumstances. So we're in a situation here. I would absolutely recommend go to the icamsr.org site and support it. Let's get some people together to let the people running these projects know that we do not want a sample from Mars brought back because of the potential for danger. We're doing enough damage to the biosphere now. What we don't need is something that gives us all pink fuzzy eyeballs or infects our ocean and displaces the diatoms as the base of the food chain. Something very, very tiny, just a microbe, could wipe everything out. And we've already placed microbes on Mars because the landers are not sterile. They're as clean as they can make them. But they do still carry, in many cases, viable terrestrial organisms which could right now be spreading in the Martian environment as we speak. So the presence of water doesn't just mean that possibly life is on Mars, but it also means that there are possibly places for life from Earth to take hold and possibly kill off Martian organisms. And what a shame it would be if we were to destroy the only other place in our solar system where there's a high probability that there's life. We might be responsible for wiping out the Martian biosphere. This goes both ways, Now, a lot of people know that I presented what I feel to be very strong evidence for fossils on Mars. And these are based not just on the images, which, there are many, many such images, and they look identical to fossils we would find on the Earth. It goes down to things such as bilateral symmetry, left and right features that are identical, and rotational symmetry, things like the pattern on a sea urchin or a starfish. Pentagonal symmetries, which do not occur in crystals in nature. But it also goes down to the conditions in those areas in times past, and the physical chemistry and environment data that we've collected over the massive numbers of data points sampled over the last few decades. With the numerous rovers and landers on the surface, we've been able to gather a huge amount of data. And in my opinion, it all points to an oceanic world where, even though the air was thin, the ocean itself, the water itself, would have been a surrogate atmosphere, and things could have lived quite successfully there. We know from the work of Derek Sears, water can exist quite easily on Mars and create mud and solutions of salts that won't freeze until the temperatures get extremely, extremely cold. So the existence of water is not an issue. The deposits of sedimentary rocks are clearly influenced by something other than simple mineral processes. What Dr. DiGregorio found was numerous holes and cavities in the rocks that are very suggestive of organisms' remains being dissolved away after fossilizing. Those cavities could be easily explained using this idea. At the end of it all, one thing is very, very clear. We have the technology to answer these questions. A simple question, is there life on Mars? It is really one of the simplest of questions. We've had the technology to answer this question for decades, and we've had tons of data to work from. We have the ability to put a rover, an orbiter, a lander, anything on that planet that we desire. If NASA really wanted an answer to this question, they would have done it 30 years ago or more. The fact that they have failed utterly to find this answer, to take the initiative and answer the question that we want to know the answer to, it indicates that they're not interested in the answer. Why would that be? Now, I've spoken to a number of people who believe that one of the goals of, let's say, Curiosity, the Mars Science Laboratory, is to find life. No, it isn't. There are 8 mission objectives, and 3 are biological. The biological objectives are 1, to determine the nature and inventory of organic carbon compounds. In other words, figure out what carbon compounds are there and what the nature of those would be. And number 2 is to inventory the chemical building blocks of life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. Well, we already know from the atmosphere that carbon and oxygen and hydrogen and nitrogen are present. We already know from the salts in the soil that phosphorus and sulfur are present. We knew that before the start of the mission. What a waste. Number 3, to identify features that may represent the effects of biological processes. Well, every time they see something that looks possibly biological, it seems they turn a rover around and go the other way. They are actively avoiding such things. The other goals are geological, geochemical, planetary process, surface radiation objectives. None of them really come to the answer. We've had numerous rovers, landers, and orbiters in the last 40 years. And out of all of those missions, out of literally a couple of $1 billion here and there, we still don't know the answer. If NASA wanted the answer, we'd have it. Well, make you, the world, a better or more beautiful place for having lived in it. I think that we can all do that a little bit here and a little bit there, and it'll add up nicely. Eliza, it's time to end the show.
Thank you for listening to Talk Universe. We hope that you have enjoyed the show. Please listen again next week.
Fantastic. Eliza's a great co-host. I hope that you're all enjoying hearing her operate. I know she didn't have a lot to say tonight on this show, but we'll have a lot more interaction with her on the next show. I'm looking at a show on smart materials. We'll see if we can't find a great interview to cover what is the verge of nanotechnology. Smart materials will do amazing things in our lives. So I'm your host, Sir Charles Schultz. Thank you for listening to Talk Universe. Let's get back together next week and do this again. From our palatial recording studios high atop our mountain lair on a remote volcanic island, this has been Talk Universe. Good night.